Okay, we on a live stream. Okay, hello everyone, and welcome to another Angels Meetup. I'm so excited to see you all joining us today from around the world. We have got 1 minute. On a live one minute. Sorry, yeah, we have got a fantastic session lineup for you. We will be talking about Angular next change detection update synchronizations. This is one of the most anticipated updates in Angular. And today you are going to learn exactly what is new, why it is important, and how it's going to improve reactivity and the performance in your application. Our speaker is none other than Nicolas Frizarin, Google developer expert in Angular and web technology, NG champion, former Microsoft MVP, developer advocate, and active community contributor at JetBrains. Nicolas is one of the most passionate voice in Angular community, and we are lucky to have him here with us today. We will also have a QA session at the end, so stick around and get your question ready. Now, let's get started. Nicolas, over to you.
Yeah, thank you. Let me share my screen with my presentation. Um, yes, yes, yes. Okay, do you see correctly the screen? I hope so.
Yes, 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 yes.
So today I will speak about the rise of Angular, the new change detection upgrade. So now it's most common to speak about synchronization, but we will see why I would like to apply this term. So thank you for the introduction. Um, so yeah, as Ida said, my name is Nicolas Frizarin. I'm a Google developer expert in web and in Angular, also a Microsoft Most Valuable Professional. Um, yeah, currently I worked on ng0, which is Angular library, Angular libraries for undesign systems. I'm mainly main contributor on it. So if you want to try, give it a try and come back to me if you want. So yeah, I'm sure you're already aware about that because a lot of information leaks on the social networks. But the next version of Angular will introduce zoneless application by default. So this means when you create a new application, by default, the polyfiles zone.js will not be present anymore inside the projects, okay? But keep in mind that if you want to test a zoneless application, currently you have to test it on a zoneless environment. So if you are a Jest fan like me, it's already exists some things to do that, okay? And it just set up zoneless environments and it works. Okay, so this looks like awesome, right? But before beginning a new journey with zoneless Angular application, I think it's time to go back in the history of Zone.js application and understand totally how worked the change detection and how signals rethinks totally this one. So first, what is Zone.js? So Zone.js is a third-party library that listens all the possible events in the browser, like a click or a focus in an input. And it also listens native web API, like the success of a promise or the callback of a timeout. And it will patch all those API with the famous change detection for dot detect change. Okay, so each time something happens, detect change function is called, and Angular will uh, raise a change detection. Okay, so what does it concretely means? This means finally the Angular application will listen the more recent events that happened to refresh the view. In conclusions, until now, Angular is based on the events to trigger a change detection, right? So Nowadays, most of Angular application we write are client-side rendering application. And just to give memories, a client-side rendering application is an application that is entirely rendered in the browser. So this means all data fetch, navigation, etc. is done on the client side rather than on the server side, right? So that's why it's quite complicated to keep a client-side rendering application with good performance, to keep good performance. Okay, so client-side rendering applications in Angular, like other frameworks or library, is represented by a tree of components, like in this image. Okay, so each cycle you can see in this image represent the components. Okay, I explained just before with Node.js, Angular are waiting an event happen. So in this image, okay, your application is totally rendered and your application wait an event. Okay. So now imagine a user will click on this component. So the last children components. What will happen? This action made by the user will trigger the first process of re-rendering. Okay, and the first process of rendering is called dirty marking. Okay, dirty marking is a process that mark a component as dirty and said that the component needs a re-render. Okay, he says, hey, you have to re-render me. Okay, so in this case of our Angular application, the user click on the last component, so automatically all the parents of these components will mark as dirty. Okay, so when all these components are marked as dirty, the change detections happen. So this is the critical way, okay, because change detection run always from the top to the bottom of the component. And so this result to render all the components. For little Angular application, this is not a problem. I'm okay. That is not performance. That's true. There is no have impact to the user experience for small application. Okay, no lags, no time before that are up to date. Okay, but the problem is if the application grow. If the applications have a lot of components with this kind of strategy, lags will appear and times before that are up to date could be significant, right? And it's not a bug, it just like the features works. So in this situation, we need to find a way to avoid re-render all the component tree, right? So that's why on-push change detection strategy was born. Okay, so instead of re-render the whole component tree, change detection re-render just the components marked as dirty, and of course not go through all its children. Okay, so imagine so some components are dirty. Okay, so change detection begin to the top from the bottom, it meets a dirty components. If it's okay, if the component is marked as dirty, it will refresh. If it's not, it not refresh. Okay, so what question is what could make a component as dirty? Four things. Okay, first thing is input change. When I say input change, it's like most input reference change. Okay, because if you pass an object as an input, the reference of this object must change. Okay, and at this moment, Angular considers that the input change. Okay, a click that call an event handler is raised. Okay, so imagine you have a button in your templates. If you click on it, but you didn't link a specific method function to this click, Angular will not mark dirty your components. Okay, we need to have a specific functions links to the click on the button. Nesting pipe, okay, that is notified with a new value, and of course now when a sign up change. Okay, so now imagine the last three components to the right of the change detection strategy change to on push. Okay, the rest of the component keep their change detection mode as two defaults. So these components, and these components, okay, the strategy of the change detection is on push, but this one, and this one are still in default mode. Okay, now a user decides to make an action on the first shade node to the left, so on this component. So imagine now the user click on these components. Okay, what will happen to the process of dirty making? Okay, because the component is still in default change detection mode, it will be marked as dirty like its parents. Okay, so this one and this one. Okay, so the rest of the other components are not marked as dirty, because I explained components with on push mode will be marked as dirty for specific case. Okay, and in this specific configuration, all the criteria are not respected. So the rest of the components are not marked as dirty. The question is why this component is not marked as dirty. Change detection is still on default mode, right? And that's true. Okay, this one, okay, because this component is on change detection on push, these components can't be dirty. Okay, because this one, it's like, you know, a guard saying, "Hey, I'm not dirty." Okay, so my child can be dirty. So finally, okay, we have just two components re-render. And this is a huge improvement, right? Since the change detection mode on push solve all our problems. And that's great. But wait, just wait. Now, imagine the events come from an on-push component. Okay? So let's analyze again the whole process, but this time the user click on the last component on the right. So this one. Okay? Here, the criteria of so this one, yes. So here's the criteria of an event handler is raised, it's respected. Okay, so all the parent components will be marked as dirty. Okay, unfortunately, so all these components will be marked as dirty. Okay, unfortunately, three components are still in default change detection components. So this one and this one and this one are still on default change detection. Okay. So what will happen when the process of change detection will happen? Finally, all the components will be re-rendered. Okay, and finally we go back to the first behavior. So there is no winning plane here. So the problem is Zone.js associated to the fact that Angular listens to the most recent events. If we take a time, it's strange to think in terms of event instead of reactivity, or in a common word, into states. Okay, so because we just until now we think in events, not in reactivity. And if we think in states, it's more easy to say, okay, this state change. Okay, so these components subscribe to this state, so these components need to change, and only this one. Honestly, the ultimate goal will be to render the only part of the templates that need to change. Okay, with this kind of behavior, this kind of behavior can't be called change detection anymore, to be honest. It's just a synchronization between the templates and the reactivity state that depends on these templates. So that's why now it's better to speak about synchronization instead change detection. Okay, and synchronization is possible thanks to signals. In short explication, when signals is consumed by a template, it become a reactivity dependency for its template. So internally, Angular will create a reactivity tree which facilitates the tracking of a change, right? So questions. What's signals? Signal is a primitive reactive system in Angular. Why primitivity? Why primitive? Because it works outside the component. Okay, so this means you can use signals in a provider or in a pipes. Okay, but you can also, of course, work with signal in a component. But signals will work outside of components, okay? Signals could be derived, can create side effects, and offer a new resource data flow for the users. Okay, and nowadays it's a good practice to use signals for state and observable for events. Okay, so signals, the goal of signals is not to replace the observable. Okay, it's just to manage the states of the view. Okay, and observable will be used to manage the events or the user events. Okay. So nowadays it's a good practice to use signals for states, and it's also a good practice to use only signals for tracking change in our components. But if we do that, okay, we have to replace all the decorator like at input or at output, as your children, etc., etc. So that's why we call it signal bus components, and that's why we have a lot of functions like input and output signal bus function. Okay. Yeah. So let's have a quick look on the signal API. Sorry. The signal functions lets you to create a signals. Okay. So these functions lets you to create a signals. So count is a signals first, and by default we need to provide a default value for this signals. So here the value is 1. Okay. If you want to read a signals, you have to call the function counts. Okay. So this dot counts here returns the value of the signal, so it returns 1 here. Computed here lets you to derive the signals in a synchronous way. Okay, in this example of code, we check if the counts signals is even or odd. And finally, the effect function lets you to create a side effect when signal read change. So is event here is a computed value, and this event return, we read the value of is event thanks to this dot is event. Okay, and at this moment, okay, because is event signal is read inside the effect, is event is automatically added as a reactivity dependency of the effects. So this means each time is event change, we will log we will log even or odd. Okay. So now, how works signals? Okay, so let's now imagine. So we have the first value is 1. Okay, so internally Angular create a value version. Value version is 1, right? Now I click on the previous button and I set my counter to 2. Okay, this signals will work like gits, so it will trigger push and pull cycle. So first, the counter value will produce will produce a new version. Okay, so the value version will be incremented to 1, value version become 2, and the value of the signals is 2. Then, because we said that, the counter value will send a push down dirtiness, saying, "Hey, I'm dirty now." Okay, so you have to refresh. So is even and the effects. Okay, so effect because is effects because the effects depends on is even and is even depends on the counter. Okay, first the effects ask the even the new value. Okay, so is even ask, okay, it asks the new value to the counter. So so it pulls a new value. The new value is 2. Okay, is even will produce a new value 2. Okay, it recomputes and it produces a new value. Then the effects will pull this new value and we enter in the side effects. Right. Now, imagine we do exactly the same, but instead of set 2, we will set 4. So now the value version will become 3. The value will be the value will be 4, right? We enter in the push pull cycles. So we push down dirtiness. Okay, so is events say no, not it will be dirty. Effects also. So effect asks to pull the new value of is even, and the is even asks to pull the new value of the counter. So value now is 4. Consumer will produce nothing. Okay, because okay, the value is still true. Okay, so we don't enter in the effects. Okay, that's quite awesome. So components. Now, that's an example of component based on signal. So I have my to-do item, right, which is an input which is required. Okay, the input have to respect the I to-do item interface. I have a new to-do, which is also an output. This is like at output, but just output function. You have input to do, which is a view child, okay, and I have a new to do, a new to function. So when I click on my buttons, I read my native elements of my inputs, right? And if I have my inputs, I emit a new input value. Okay, that's how it works. Component-based signals. So that's nice. The goal is near, okay, but now the component is refreshed only when the signals that it depends on change. Okay, so let's see our previous schema and adapt it to the signal magic. So now, these components, the change detection of this component, and this component is on push mode. Okay, this component is only based on signals. These components and these components, and finally these components are still on the default on change detection. So now imagine a user click on a specific button. Okay, this click raised call a specific function. Okay, by raising an event, and inside this function, we set a new value for these signals. So just very important things, keep in mind that these signals is read by the templates, right? So at this moment, okay, only one component will be marked as dirty, okay? And because these components and these components are still on the default change detection, finally, we will refresh just 3 components, okay? So now, if we have used only components based signals and change detection on push mode, only the last component should be rendered. And this is called fine-grained reactivity. So the question is how to migrate easily your components on signal-based components. And that's very cool because Angular have already a schematics for you. Okay, this schematics is just ng generate at angular/core.signals. So the schematics will not create signal variable for you, of course, but it will migrate all your at inputs and at outputs annotation to the associate input and output signal function. Okay, first, and it will also migrate all the queries decorator like add view child, add content child, etc. to their associate signal function. So now you will have access to view child, view children, content children's signals function. Okay. So with that in mind, okay, so and thanks to the possibility to derive a signals or create side effects for a specific signals, it's totally possible to imagine a world without the previous life cycles of Angular, like enjoining it or enjoin change, you know that? And yeah, now when you create new Angular components, you have to sync your components without life cycles hook. Okay, so just I will give you, this is a specific, I know, just to show you how it works. Okay, these examples have no specific goals, to be honest. So I have my name is input required. I have a last name, which is a computed of this name, and I added that at the end, though. Okay, I have a name control, which is a new form control. I'm sure you already know that, but signals forms will arrive too. There is already a RFC in Angular repo, so you can go on it and read the RFC, which is very interesting. And please give all the comments you have. And in my constructor, I license my name control value change. Sorry, I have mistakes. And when my component is destroyed, okay, I unsubscribe to the control change. And I have created an effect, and this effect read my name, and each time my name change, I will patch my control value, right? Okay, this is less lifecycle example. So I create a map. I think it's better to understand and create a map to show you how you can simply remove the older life cycle. So if you want if you want to replace on units, you can just use computed, it works, or linked computed, right? On change is also replaced by computed, link computed, effects, or signals in general. Do check will be replaced thanks to signals and after render function. If you want to replace after view init and after content init, you can use after next render. Okay, so this is how works now. Now Angular. What is very important is avoiding using effects. Okay, I'm sure when you want to, you have a signals and you want to derive these signals to set a new signals. The goal is to totally avoid using effects. It's better to use computed or links, and that's why I create a tree reactivity choice to explain that. To try. So first is, do I need a reactivity? If the answer is no, question is, do I need access DOM in a non-reactive way? If the answer is yes, you can invoke the signals in after next render callback. Okay, if the answer is no, just read the signals. Okay, so if I need reactivity, the question is which kind of reactivity you need. If it's observable based reactivity or is a state based reactivity. If it's an event or stream reactivity, go to observable. Okay, and if it's on a state, go to signals. Okay, so then new question: can I derive these signals? So first is no. Imagine if it's no, just asking you again, can I derive these signals? So if it's no, are you sure that you can derive the signals? Okay, so if it's no, you have to create a side effect, okay, on a non-reactive API. Okay, so now the question is when? When after render effects, if you need to perform this effect after rendered, and if it's aid components synchronization, okay, you can use effects. Okay, if you can derive the signal, if it's yes, you have to ask yourself what is the type of derivation, if it's synchrone or asynchrone. If it's synchrone, okay, another question is if it's writable, if the type of derivation could be writable during the life of your components. If it's yes, use linked signal. If it's no, use computed. Okay, if it's the kind of derivation is asynchronous, you have to ask the type of the return. Okay, if it's premise, you can use resource. Okay, or you can use HTTP resource now. Okay, and if it's not observable, you can use RX resource. Okay, this is a reactivity tree. Can give you all my slides if you want to give you the possibility to make a better choice in the future. Yeah. For me, it's finished. Thank you very much. You can follow me on Twitter or X or LinkedIn. Sorry. And if you have questions, you can ask. Just last things, I've created a training in Angular. Which is a repository in Git. There is a lot of slides, and there is 30 practical exercises with solutions and README to help you to create your own solutions. So if you want, I can give you also the link of this training. It's totally free and open source. If you want to make some contribution or simply asking me help, you can it's not a problem for me. So if you want, I can also give you this train. And so thank you. And let's have question now.
Yeah, yeah. About mm, you can share in your page also if you want to share me too. I can share on LinkedIn and Twitter.
Yeah,
Any link or any PDF.
I can
Yeah.
show you immediately the link
Yeah.
and
Okay,
the slides.
let's switch to questions. We have okay, we have more questions here. First question from a caller: how does the new change detection synchronization interact with the angular signals under the hood?
Yeah, so under the hood, as explains, when you create a components based on signals, finally, Angular will create like, a tree of reactivity. Okay, so under the hood, when the if your signal is called in the template, so this Angular will create a dependency in this tree. Okay, and if the signals change at this moment, Angular know which parts of the templates change, and it can refresh this part of templates. I'll give just a few words because this is still experimentable for the moment, okay, because it just refresh the part of the template that changed, not the whole components. So for that, you have the HMR options activate by default, right? But if you do that, yeah, if you do that and you want to use the differ templates features, okay, right? In development mode, it's not worked. It will not create a new chunk. Okay, it will just works in production mode. So if you want to just check if your add differ block works at this moment with signals and HMR, just deactivate it in development mode and then reactivate it. It's like a trick, okay? But for the moment, it's like it works.
Yeah. Okay. Second question is from Salim by uh, in a zoneless how does synchronization behave differently compared to zone-based apps?
Okay, that's a good question. So if you have no zone JS polyfiles, right? So you don't have, um, you know, you don't have patched all the API like click, focus, promise, or something like this, okay? Because Zone.js polyfile is not on the application. So in zoneless application, we don't listen the most recent click, okay? In zoneless application, we listen uh, the signals that is read. We listen the change of these signals, and when this signal is changed at this moment internally, Angular will call application dot tick.
Okay. Okay. Second, next question is: does this update change the timing of lifecycle hooks like ng on changes or ng after view init?
Now, for someone's engine change and engine needs all the life cycles are not deprecated. You can use it in your application. Okay, so even if you have an input based signals, okay, and you create engine change life cycles, you will enter in this life cycle. So it's not a problem. But because signals offers the possibility to derive the states or create side effects, and because you have some hook like after next render effect, it does not make sense anymore to use enjoin change. For example, imagine enjoin change take as the first argument changes, which is the simple changes, okay, and generally in the enjoin change hook, you check the previous value of a specific inputs and which is different of the current value, and at this point you do something, right? But thanks to Sanders, you can create effect a lot of effects. Okay, with engine change you can create just one engine change, but with effect you can create a lot of effect. You can create an effect by each input if you want. It's not a problem, right? And that's why. I think it's a better way now to sync your components with just hook, signals hook.
Yeah, okay. Um, the next question is, could this update influence how Angular handles states management libraries like NGRX or Akita?
Oh, that's great question. Very understand. Um, yeah, I think okay, it depends of your application. Okay, I think NGRX Signals Store is a super library and it's very awesome. Okay, but I think this kind of library needs to be introduced in your project. In if your project tends to grow a lot. Okay, and if you have a store that is quite complicated to maintain. Okay, but if you just if you are a small application, I think we don't you don't need to have a store, to be honest. Okay, but yeah, if you want to work in your application just with signals and a store, I think it's a good idea to go to NGRX Signal Store because this library is great. And Akita, if I remember well, it's a library created by Netanel Bazal. Sorry for this name. I hope I spelled it correctly. But if my remembers are well, I think this library is still based on subjects and behavior subjects. So if you want to use it's if you want to use this kind of library, you have to use the bridge between observable and signals, and this bridge thanks to two signals or two observable functions. Okay, so signals are not the goal to replace observable, and signals the goal of signals is not to replace all or store library.
Yeah, okay. And the last question from Yelin. Yelin, I'm sorry, the pronunciation. Okay, what are some examples of after render?
Can you repeat, please?
What are some examples of after render? Maybe it's just
Oh,
example for after
oh,
render.
oh,
Yeah.
okay, so after next render will happen when the application is rendered. Okay, it's like ng after viewing it or ng after content in it. So this hook, this signal hook is called just one time, to be honest. Or you can also, if you want, uh, imagine click on a button. When you click on a button, register again this hook. It's possible. Okay. After render is a signals hook that is called every time the change detection is the synchronization is done. All right. So this life cycle, when it register, it will be called each time change detection happen. It's kind honestly it's like the ng do check method. It's the same hook.
Okay. Okay. Also, oh, okay. Also, we have a comment from Jerome. Akita is deprecated, though not
Yeah.
maintained anymore. It is being archived on 1st May. So yeah, thanks, Jerome. Yeah. So yeah, we now we kind finish it. A huge thanks to Nicolas Frizarin for sharing such as valuable insight into Angular's upcoming change detection synchronization update. I'm sure many of us are living today with a deeper understanding and some great ideas to try in our own project. Thank you to everyone who joined us live, ask the questions, and participate in discussions. Your engagement is what makes this meetup so special. If you enjoyed this session, don't forget to like the video, subscribe to our channel, and hit the notification bell so you don't miss the future events. You can also follow us on Twitter for updates and announcements. Until the next time, keep learning, keep building, and keep sharing with the community. See you at Next NJ has a meetup. Bye everyone.